Hello everyone and welcome to today's video section. So in today's session I'll be introducing you to data analysis and data visualization basics. So before we start, I would like to introduce you to data, then data analysis, then we look at the principles of effective visualization. So let's start. So what is data? What is data? What is data? So data is a raw unprocessed information collected from various sources. Now there are data everywhere now, on your phone, on the internet, the bank, the marketplace. You go different information, people writing, people uploading to their servers. There are data everywhere, but these data, they are not useful if they are not processed. All right, so that is data, and it can either be quantitative or qualitative. So what we mean by quantitative means that it is numerical, it is a number, whether with decimal place or not, or a whole number, it is quantitative. Then for descriptive is that it is qualitative. It just have some qualities like the color, the what else again, any form of quality that you can use to describe something. It is descriptive. All right, so the important is that it serves as the foundation for insight, for decision making and process optimization. When you base your decision based on data, then you are sure to make the right decision. This has been proven. All right, so data is an unprocessed information that can be collected from various sources. Like now there are a lot of data on the internet, from social media, from databases, from the cloud, and so on. And if we might look at the different data types, so we have data based on the structure. Data that are based on the structure. So the first one is structured data. Structured data are organized in predefined format like tables or spreadsheet. The way we put our data in Excel or database in rows and columns, they are called structured data. They are well structured. All right, they are structured data. And we have semi-structured data. They don't follow rigid structure, but hashtag or markers for organization. So I'll just say that semi-structured data have structure to some extent. Means that they are not completely structured, but they just have structure to some extent. All right, that is semi-structured data. Why structured data are well structured and they are in rows and columns? Semi-structured data are data that have structures to some extent, but not fully structured. All right, example is this XML or this JSON file. All right, this one you see on the screen right now is a JSON file. All right, so the unstructured data does not have any form of structure, not organized in any predefined manner. Or you would think that a video is a structured data. No, it doesn't have any structure. If you pay attention to sound, you know that sound does not have any form of structure. Imagine hearing a local music, then you are hearing a hip-hop music. Can you just compare the sound? They don't have structure. So they are unstructured data. These are the basic type of data types based on their structure. So we have structured, semi-structured, and unstructured data. Now we have data based on their content. Based on their content, we have qualitative and quantitative. Of course, we've stated before that quantitative is anything that is made up of number, like quantity, that you can measure it, quantity. Then qualitative, it is any of the qualities that makes up the data, like the column. So in qualitative data, we have two types, the nominal and the ordinal. All right, so ordinal are ordered. Example, educational level, we start from primary school to secondary school to university. All right, you got I can't say secondary school can be measured. It's a measured data, no, but it has order. There's an order in it. All right, like I can say level one, level two, and so on. But it is not a quantitative data. So it is an ordinal data in the qualitative data based on the content. Then for nominal data, it says these ones are without order or rank, like color or let's say the color of your eyes, the color of your hair. All those things are just nominal data. And we have quantitative data, and there are two types: discrete and continuous. What you mean by discrete is that they count distinct item like number of book, how old you are, what's your weight, what's your height, their quantity. All right, but the continuous data are data that are continuous, like temperature. And what else again can I put in continuous data? Can say date is it's a continuous data. All right, so these are the different type of data based on their based on their content, their qualitative or quantitative data. Now, data can be classified into the various form. Also, the data can be classified into the various form. They can be string. What we mean by string is that they are text, ABCD. All right, they are text or and characters. Also, they are string. Anything that is text and special character, they are all string. While integers are whole number. Like when I say 5, 10, 2, 1, it's a whole number. Then float are number with decimal place. All right, like 2.5, 0.1, they are float. And lastly is boolean. Boolean data type are those that have only two options, like yes or no, true or false, 1 or 0. I think this is purely is clearly is clear to all of us, right? So I say string is any ones with text or special characters, while integers are whole number, while the float are numbers with decimal place. Then boolean are the ones which are true or false, yes or no, 1 and 0. They are what? They are boolean. A boolean data type. I think that's very clear to all of us. Then we'll go to the next option. Now, how can we get data? So data can be gotten from various sources. All right, but we have primary source. So data that is collected directly from the original source of the data is a primary source. Like now, I give you a questionnaire to fill for me. I collected that data at first hand. It is a primary data. Meanwhile, data that is collected from a data collector or stored location are not directly from the point of origin. All right, like you collected the data from someone that collected it before from another person or another source, then that's the secondary data. So please take note. And I want to tell you that the more primary data are more authentic. All right, and they don't have bias, in a sense that the person that collected the data have not changed anything yet. All right, so that is primary and secondary data source. Now, what are common data source that we have? All right, you can get data from survey and experiment. You give people questionnaire through the internet, through forms online, and they fill it for you. All right, then you can script website. You go to website using your skills and get data from those website. The process is called web scraping. Then you can get the data from such source also. Then we have the ones in spreadsheet that is very common to us, that we usually use and get from the internet. They are in spreadsheet or CSV. Then that's another data type source. Then we have APIs. Now, especially for those who are into programming, that's how they get their own data. You go to a website, things are happening there, data being exchanged, and you don't know. Most of those websites, they use API. All right, application programming interface. Then we have database. All right, I think this is the most common source of database, because we fill and we work with website, and most of all those data that we feel on the internet, they go directly into what? SQL and no SQL databases. So these are the most common sources of data. Now let's talk about data lifecycle. Let's talk about data lifecycle. So what is data lifecycle? Data lifecycle The data lifecycle represents the entire journey of data from its creation or acquisition to its eventual destruction, ensuring proper management and use at each stage. All right. So the process in which data goes through, from when you get the data from the source till when you use it to make your final decision, and the action you take on that data after you've used it. All right, will you store it, will you destroy it, and so on. So what's the purpose of that? To ensure that data is effectively and securely handled through its existence. All right. So because if you don't effectively handle your data, if unauthorized person have access to that data, some bias might come in, it might change something. And if you don't secure it, if someone that doesn't need to get hold of that data sees it, person can use it for something not good, or something that might destroy the reputation of the company. All right, so you need to protect your data securely. Then to support compliance with legal, regulatory, and organizational policies, sometimes you even go to website, because website also take your data, but they need to give you some consent, which goes along with legal requirement, that you need to let someone know before you take his or her data, to maximize the value delivered from data while minimizing risks like misuse or breaches, ensuring data remains accessible and meaningful when needed. Lifecycle optimization, efficient managing resource and storage costs. So these are all the major purposes of data lifecycle. All right, so you create data, you store it, you use it, you share it, you archive, and you destroy. So these can vary depending on the organization. That's one thing I want to point out. This data lifecycle can vary depending on the organization. The data lifecycle for let's say a banking industry is not the same for a health industry. All right, and some of these places, they destroy the data, they don't want someone else to see it, but some of them, they don't destroy it, they need to keep it for reference purpose. All right, so depending on the industry or the platform, this data lifecycle might vary. I just wanted to point out that to all of us. So data lifecycle is the entire process in which data goes through from its creation to, should I say, eventual destruction or archive. Some archive their own, while some destroy it. So data lifecycle varies for different industries. So the next thing is, okay, still on the data lifecycle, the creation, the initial generation or acquisition of the data from various sources, storage, the process of securely saving data for future access and use. So you can store it on the cloud platform, or local servers, all right, or on premises server. On premises, that you have something in your physical office that stores the data. Then usage. The usage is the active phase where data is accessed, processed, and analyzed for insight or operation. All right, that time where you use it. So after you finish using it, you archive it. That's to keep it somewhere safe, or you destroy it. That's the data life cycle for you. So I would have to skip this one for now. You can go through this material. I'll be dropping it. It says data lifecycle flowchart, to just to determine how you work with your data. Just like I've been saying, some you might you archive, or you can destroy the data. Okay, so if you follow this start button, it will say determine the need for data. That's the first process. Which data do you need? You determine the need for the data, then you create or capture the data. Do you need to, some data are created automatically, while some you need to go and capture them. Like, let's say for a website, as people log into that website, the data is being captured. Is being captured. But some you need to go and give them form for them to give you data. All right. So then after that, you prepare for use. You prepare the data for use. Then is data ready for use? If it is no, then you go back and prepare it. All right, we can call this data cleaning or data transformation and so on. Then if it is ready for use, you can do what? Data is now in use as needed. So when you're using it, then you go to the next stage, which is what? Data is managed, modified, stored, protected, and secured. All right, then is data still needed? If you still need data, you say, is data still needed? Like after you finish, is it still needed? If it's not needed, no, data is what? Destroyed. All right, like let's say for a health facility, what do you think will happen to that data? I want to get your comment. What do you think will happen to a health industry? Would they destroy the data or would they save it? Let's say they test for someone with a very severe sickness and they found out something. What do you think will happen to the data? Will they destroy the data or will they archive it? I want to get a comment from you guys. So if you want to store it, you can go ahead and store it. If it's needed again, you go through the same process again, or you still maintain it or like update it. All right, so you can follow this flow chart to determine the need of data in your organization. The importance of data lifecycle is step 2, for storage of large data, analytics, organizational efficiency, security, and privacy, compliance, and data governance. Now, we've been talking about data. Now, let's go to the main thing that we're here for, which is what? Data analysis. So, what is data analysis? Data analysis, it says, is the process of examining, cleaning, transforming, and interpreting data to extract meaningful insight, identify pattern, and support decision making. All right, so if you follow this definition, the first thing it says that you do what? You examine the data. Now we are removing the process of collecting the data. This time you already have the data. So what do? You examine the data. If the data is not clean, you go ahead and do what? You clean it and transform it. You clean it and transform it. You can even analyze it here. You analyze it and interpret the data to do what? To extract meaningful insight and identify pattern. Because what you have question to answer. So the question you want to answer, or what you want to do, is that you want to use the data to support your decision that you want to take. Should I go to this school or should I go to the other school? You browse the internet and you saw one other school, and you compare with your previous school, and you decided to go to that latest school that you saw on the internet. So you've taken a data driven decision. All right, so that is data analysis for you, the process of examining, cleaning, transforming, and interpreting data to find meaningful insight, identify pattern, and support or make data-driven decision. So we can apply data analysis to all aspects of life, from our finance to marketing to education to business and so much. All right, so we can apply data analysis in all aspect. All right, so data analysis, maybe let me skip one for now. So what are the steps for data analysis? What are the steps for data analysis? You can't just go into collecting data anyhow that you just want to analyze it for no reason. So you need to have a reason for carrying out a data analysis. What's the question you want to answer? Or are you just doing it for nothing? So the first thing is that you need to define the question that you want to answer. I want to find out, in this school, is this thing more stronger here or the other side? Like, you just define your question, then you collect your data. You collect the data to support that question that you want to answer, because you want to base it on data. All right, now the data that you collect, if it is not clean, you do what? You go ahead and clean the data, you transform it, and you analyze it. After you analyze it, you can now see insight from the data. And if maybe what you try to answer, you didn't see any answer, you do what? You start through again, you embrace the failure and start all over again. Now, what is the question? Coming up with a hypothesis and figure out how to test it. To come up with a question, just like that's what hypothesis is all about. Coming up with a question and figure out how to test it. That question that you want to find out, is it in a business or in the hospital or even in your own personal life? You can come up with a question. Why do I do so? Why do I do this or this? Why do I? You can just then you support your question by collecting data. So data is needed to answer defined question and are collected from various sources. So you collect the data from various sources, then you clean the data, because most time data can be dirty. All right, even though they are structured in rows and column, they can be dirty, or they might not be consistent. They might not be consistent in their character, in maybe their decimal place in a particular column. So data can actually be dirty, so you need to clean it and transform it. You transform the data. Data is structured in a format that is appropriate for required analysis. So that's what transformation is, to the format that you can actually use to analyze answer question. So the next thing is that you analyze the data. What you saw, you can see some people doing using Power BI, Excel. You can actually do that. All right, that's analyzing data. Then from there you get insight. The result of analysis is shared with audience either as report or visualization. All right, which you can use some business intelligence to do. All right, so if your question was not answered, you didn't see anything, you can start the process all over again. So there are 4 basic types of data analysis. So descriptive analysis is the first one. So it gives a description of the data collected, usually in form of summaries and trend. To describe something, you want to describe everything about that data. All right, then the next one is diagnostic. If you follow this term very well, you know that to diagnose is to find out. This analysis identify the cause of pattern or anomalies in the data. To find out something, to find out what actually happened or what's happening, it diagnostic type of analysis. Especially, I think people in the health field, they do this every day to diagnose. All right, then we have to the predictive analysis. This type of analysis is used to forecast future trend using models that find pattern in the data. This way something like regression comes in, to predict what will happen in the future. That is predictive analysis, when you are trying to find out what will happen in next month, like let's say in finance, let's say even for rain, you want to predict if there will be rain tomorrow. Predictive analysis is what you are doing. Then we have prescriptive. This analysis is used to recommend action based on trend in data. Like let's follow the word, and I like thinking of like a doctor prescribing a drugs for me. So I found out the problem. So when they prescribe a drug for me, that's the solution. So prescriptive is a type of analysis where you try to give solution to a problem. Prescribe, do it this way based on data. All right. So descriptive, you are trying to describe what happened. You are trying to find out what happened. The diagnostic, you want to find out the cause of that problem. This one, you want to predict what will happen. Why prescriptive? You want to give solution. All of them based on data. So these are the various type of data analysis. So tools for data analysis, and it said data collection. tools to gather data from various sources such as survey. We've talked about this one before. You can use Google Form. You can use your skills. If you know how to code in Python, you can use it. Then you can still use it to clean your data. You clean the data, you store the data, then you visualize the data. We'll still talk more about these tools in upcoming session. So, principle of effective visualization. Visualization is purely, putting your data into chart, because it's easy to understand when you visualize data than just viewing mere numbers. All right. So, some of the things you need to know when trying to visualize your data is that you need to know your audience, the people that you want to show this chart. Like I usually tell people, don't use any advanced chart that someone or your audience don't know. It will be very difficult for them to understand the information you are trying to pass to them. So don't use advanced chart that your audience don't know. Maybe if you're working with fellow data analysts or people that are into data, you can use those charts, but you need to know your audience, that these people don't need advanced charts. So know your audience is the key. Then you choose the right chart. The same thing I'm still saying. You don't go and choose advanced chart. Choose the right chart. There are various charts for various purposes. Like if you want to visualize, like say time, you use a line chart. So there are many others. There are many other principles for effective visualization. You make your chart very simple and focused. Simplify the chart. Use appropriate color. Very, very important. Color is very, very important in visualization. All right, you don't use color anyhow. Some people have night blindness. Some people don't see some particular color. Some people, there are some principles you need to follow for when choosing colors for your visualization. And you label your visualization clearly. Put every detail that will enable people to see what, or understand what you are trying to show to them. All right, so I was still talking about to know your audience, choose the right visualization, make it simple. Then you use appropriate colors, and finally you label clearly. So what are the various visualization tools we can use to visualize data? Number one is Power BI. So Power BI has gained a lot of traction in the last 5 to 10 years now. All right, so a lot of people now embrace Power BI for their personal and organizational project. So Power BI is used for data visualization, and it's actually does a lot of good job. All right, so the next one is Tableau. Tableau is almost the same thing like Power BI, but I think for me I will go with Power BI first before Tableau. Then if you prefer coding, if you prefer or you like coding, then you can go for Plotly. There's still some Python visualizations that you can use, like Matplotlib and Seaborn. All right, so you can also use these free tools, because Power BI and Tableau are not free. All right, only the desktop version. But the Google Data Studio, with Google Data Studio, you can visualize for free, and we have Microsoft Excel too. All right, so depending on your need, you need to choose the right platform. All right, so in conclusion, data is the foundation for data analysis. You need to know how to collect your data. Data collection, getting data is one of the hardest thing for analysis. You might have many questions to answer, many things to analyze, but when the data is not there, there's nothing you can do. So data is the main thing. Data analysis transforms the jargon in data into executive insight. And data lifecycle management ensures the management of the entire process. And finally, effective data visualization enables that the user audience can use the result of the analysis. All right, so guys, this is all I have for today. So that's all for today's class. I hope you enjoyed this section. So if you have any question, just drop them in the comment box. All right, drop them in the comment box and I will reply to you. All right, so thank you for joining for this session and see you again next time.